Hey everyone, so it seems like everything nowadays has some sort of biometric login. My work laptop has a fingerprint scanner, which I love. My phone also has a fingerprint login. Like, who even types their password nowadays? Just like everything else, I want my workstation to have a biometric login. And I want to make this with parts I already have. Because who just has random microcontrollers and fingerprint modules lying around? So I came up with this fingerprint login device. It's the Just a Fingerprint login by Just Barran. And I'll tell you how it works after a word from this video's sponsor. You don't have any sponsors?
How you are, you just have to say that you're fine when you're not really fine.
So the device is pretty simple. When you're on the login screen, you rest your finger on the sensor, the light will come on, and the wrong finger will do nothing. And if it's the correct finger, it types in your password for you. To be honest, it's the heights of laziness, but I mean, who isn't lazy nowadays? And isn't that the point of automation, to replace humans? I mean, to make our lives a little bit more comfortable. Isn't that right, Elon Musk?
Who knows?
Let's dive deeper into how this project works, all the features I packed into this tiny device, and why a simple weekend project turned into a month of work. This is Just Barran, and on this channel, I do just about anything you can do yourself. So I didn't want the device to need any extra software or drivers. The idea here is to follow the KISS rule. Keep it simple, stupid. I want something that will do the same thing my fingers do.
That's what she said.
The point is to simulate a keyboard to enter the password and use a fingerprint sensor to verify and trigger it. It also needs to be as small as possible to avoid too much space on my desk. I mean, the cost of real estate on my desk probably rivals that of Dubai. So here, size does matter, and the smaller the better.
Well, that's not what she said.
So I could 3D print the housing to get it nice and small. Simple, right? Let's head to the lab. Now I have 3 different fingerprint sensors lying around. 2 of these are based on the AS608 chip you would see in most Arduino projects, while the GT-521F32 by sparkfun is less common. Now I could sit here and compare these sensors, but I know you don't got time for that. You just want to know what to buy. So I picked the GT-521F mainly because of its size and how elegant it looks. All sensors can store 100 prints, and if 100 fingers can unlock your computer, then what is the point of even having a password? So it really boiled down to which had the best form factor. And the GT-521 really had a nice look about it. Like, look at it. Now remember, when it comes to electronics, looks doesn't matter, and don't let anyone tell you otherwise. For the microcontroller, I could have gone with the Arduino Pro Micro. I have used this in previous videos like my DIY PC drone controller video. It's easy to use and supports USB HID, so it can act as a USB keyboard. Still, I recently got this super cute Seeed Studio XIAO that can also do USB HID. It's hands down the better choice with a 48 MHz clock and 3.3 volt logic. Funny enough, XIAO means small in Chinese, and me being 5.6, I know what it feels like to be XIAO. It's built around the SAMD21, which packs a 32-bit ARM Cortex processor, which sounds really fancy and cool, but it doesn't mean it could run Minecraft. Or can it? The GT-521 fingerprint sensor also uses 3.3 volt logic, so there's no need for any logic level electronics. Basically, it's the definition of relationship goals. Something worth noting is the code at the end of the day should be still compatible with the Arduino Pro Micro with little modifications. The first goal was to get the XIAO to work, so I followed the guide from seedstudio.com, which included adding the XIAO to the Arduino boards manager. If you don't know anything about Arduino or microcontrollers, you can check out my Arduino playlist linked in the description. Once the XIAO was set up, you have to run the blink LED code as always with any microcontroller project. Adding the Arduino keyboard library, I can add a button to trigger a series of keystrokes. This is great if you want to make those keyboard macros for those GTA cheat codes, or change the tab when your mom walks in unexpectedly. Now to add the fingerprint sensor. I followed the wiring guide from sparkfun. This sensor required a pair of these QWIIC cables also sold by sparkfun. I will link them in the description. Or you can do like me and cut one of these double-ended ones in half and solder headers on both ends. Note the colors of the wires are not standard, so black does not mean ground. I will link this circuit diagram in the description. The connector on the right is for the capacitive sensor. It lets the microcontroller know a finger is on the sensor. The other side is for the data lines. You can also solder a USB cable to the underside and connect the sensor directly to the computer, which I thought was pretty cool. You can download and see your fingerprint, among other things. Definitely something for a future project. In Arduino, I added the sparkfun library by Josh. You can use the blink example to test the wiring. It was great to see everything working on the first try. I first loaded my fingerprint with the enroll example. I then used the ID example to verify my fingerprint and log me in. It worked. Well, so I thought. Later in the day, I tried the fingerprint sensor again and it was not working. And I had to type in my password like a caveman again. This is where the problem started. The light did not come on, which told me one of two things could be the problem. Either the capacitive sensor stopped working, or there was a problem in the code. I unplugged the board and plugged it back in, and everything was working fine again. After spending some time, I realized the problem was in the library. What happened was, they would send a command to the fingerprint sensor and use the while loop without a timeout to wait for a reply. This sometimes may never happen, because UART isn't always accurate, the sensor could be busy, or the wire could have noise. A while loop without a break condition is essentially like cancer, which can eventually lock up a code. So I decided to write my own library. This is not to discredit the library by Josh. It works, but it was last updated 4 years ago and it was limited to only software serial. So it was something quick to get started. After a week of reading the datasheet and testing, I finished my own library. This has more core functions needed for some of my future projects, and most importantly, hardware and software serial. This library would be available on Git for anyone to use. I could even disconnect the sensor and plug it back in without the code locking up, something Josh's library can't do. The code didn't crash after a week of use, so it's safe to say that it's working great. For the housing, I jumped over to Fusion 360. I wanted it to have a small footprint and be simple, so I thought two parts, a base to hold everything and a simple cover on the top. I designed the bottom so the XIAO can slide into place. The cover would then lock in with an opening in the back for the USB-C connector. And I added some standoffs to hold the fingerprint sensor. This would use some M3 screws. This would also allow enough space for the wires to pass. I rounded all the edges and sent this to my 3D printer. It came out great, better than expected. Test fitting, I realized the side clips was a bit too out and I had to use some sandpaper to bring them down. But it worked and I think it looked amazing. The last thing to do was to solder up the wires. I cut the wires down to size to fit inside. And this is where I realized a problem in my slide-in design. I had to solder the wires as far from the edge as possible as to not mess up the sliding process. It was a tight fit, so bear that in mind if you use this design. But it worked and I think it looked amazing. I originally had coded a password, and you can do that if you want, but what if I wanted to change the password later? Would I need to reprogram the whole thing over? So my solution was to store the password in flash storage, among some other things. This is a non-volatile storage, or NVS for short, and it's used to store information that isn't erased when the device powers down. That way, I can make a user interface to change a password or fingerprints at any time without editing the code. So 700 lines of code later and a quick upload, and the device was finished. When the device is plugged into the computer, the LED should blink once, indicating it is ready. The flash is cleared when we upload the code, so it goes to its default passwords and it removes all fingerprints. Generally, the device would be in sleep mode waiting for a fingerprint, but first we need to set it up because right now it has nothing in the memory. To do this, I open up the Arduino serial monitor, or any serial monitor would do. The baud rate is 9600 and we want no line ending. Resting your finger on the sensor would make the device think it's trying to log in, and it wouldn't wake up the device. You need to do a simple tap and it will wake up the device saying enter password. I have set the default menu password to 12345678, so I type that in and press enter to send. Note, I have set this to 5 tries before the entire memory is wiped and fingerprints erased. Also, the password needs to be at least 4 characters long. A menu would show up. From here, I can change the device password, change the login password, and add a new fingerprint, among other things. It is recommended to change the device password, but I think the default is pretty secure. Send the number 1 and you will be instructed to enter a new device password twice. If you take too long or if the passwords don't match, the setting would fail. If both passwords match, your password is changed. Now let's change the login password. By sending 2, this would be the password for your computer. The same goes here as the device password. But just note, the serial field doesn't have an auto hide feature, so be careful of who's behind you. Then you can check if any prints are added by sending 3. Adding a fingerprint is also easy. You send the number 4 and follow the on-screen instructions. You would have to press your finger 3 times for it to be stored. If there's an error at any time or you switch fingers, the process will be cancelled and you will be sent back to the menu. Great, my fingerprint is stored. You can check any of your fingerprints by sending the number 5 from the menu. This will return if it is found. Lastly, if you want to clear all the fingerprints, you can send the number 6. Leaving the device alone for 10 seconds, you will relock the device, and after 20, it will go back to sleep mode waiting for a finger. So in the end, we get this. Super simple, right? And I've been using this for the past month with no issues even when unplugged or powered down. So I'm pretty happy with how it came out. Now the last thing for us to talk about is security and encryption. Something to add in the future would be to encrypt the password with a random key before storing it in flash memory. This is important to make it more difficult for someone to, let's say, write a code to retrieve that data from flash. Now Arduino automatically wipes the flash before programming, but someone else could just use a different software that doesn't. Another thing I can do is to use the unique serial number from the fingerprint sensor to pair that sensor with the XIAO. This is similar to what Apple does with their fingerprint sensors. This is in particular important since the matching is being done on the GT-521F and not the XIAO. So someone can, let's say, try to switch out the fingerprint sensor with one that already have their prints on it. I can also seal the housing in resin so that someone has to physically destroy the device to open it, which is actually something some manufacturers do. So long story short, this is a really fun project, but it should not be used to protect a bank vault. Still, it should still be acceptable for your personal computer, once you don't have any hackers in your family. And I think if you did, this would be the least of their worries. So I hope everyone liked and enjoyed this video. There are additional features I am thinking about for version 2, like let's say storing multiple passwords. So let me know in that comment section below if you have any more ideas, and while you're down there, consider hitting that like and subscribe button if you didn't already. It goes a long way in helping the channel. And as always, this is just Barran, and I will see you in the next video.